Alrighty folks, today I want to talk about the importance of bonding the neutrals of control transformers. Now, this idea came to me because I was thinking back to my early days of troubleshooting and trying to diagnose faulted machines, and I remember getting hung up and stuck on reading weird voltages to ground. Like I would test from hot to ground and I was getting 70 volts, and neutral to ground I was getting something like 30 or 40 volts when I was expecting 120 volts to ground from my hot and 0 volts to my neutral. Now, this was simply caused by the lack of a bonding jumper between neutral and ground. Now, let me give a little breakdown on how these control transformers work. Just like every other transformer, you have primary windings and secondary windings. Your primary windings are being fed by either 240 or 480, some sort of higher voltage, and your secondary windings are producing 120 or 24 volts. Something low, something for push buttons and other input-output devices like that. The secondary windings are energized through inductance. The primary windings produce a magnetic field which cause electron flow in the secondary windings. The secondary windings are not being energized through direct contact, and because of that there's no ground reference to these secondary windings and any part of the circuit afterwards. And because of that, we have to create a ground reference. And we do that by throwing a little bonding jumper between the neutral terminal and any sort of ground. And what this does is that takes away those weird funky voltages that you see. Once you throw a little bonding jumper in there, you will go back to getting 120 volts to ground on your hot wire and 0 volts to ground on your neutral. I see this a lot in older systems where back in the day it wasn't really common or standard to bond the neutrals, and because of that you got just such weird voltages. And I wasted a whole lot of time running around thinking that transformers were bad, and then when I came to this conclusion and when I finally learned that, I was super scared to throw these bonding jumpers in because I was reading 40 volts neutral to ground and I was worried I was going to short the system or blow up their transformer. Don't worry, electrical theory still applies, even though it's in a control panel and not for a primary service or anything like that. It's just like your house. You bond your neutral at the first point of overcurrent protection. The same thing in these control panels and these control systems. If you're reading funky voltages out there in the field, something like 70, 80 volts to ground when you're going hot to ground, and something like 30, 40 volts from neutral to ground, it's most likely that your control transformer is just not bonded. So let that be a first step. And if you go to a customer's facility and their control transformer isn't bonded, throw in a little bonding jumper for them. It'll save you so much time and headache and make your troubleshooting process so much simpler.